Okay, this circuit here, and then for part A, I say, rank the currents in the three resistors from greatest to least. So the current that should be the greatest should be IA. Hopefully you see that, because all the current has to go through this. And then hopefully you see that IC and IB comes out something like this. Okay, for part B, if you don't get it, make sure you ask, because I'm rolling. Justify, I would say all current must pass that resistor. Has to. And then for B, oh, just kidding. Yeah, for B, 2R is greater than R. Therefore, IB is less than IC. So for C and B, that's the logic. Okay, I'm going to part B here. Rank the voltages across the three resistors from greatest to least, with number 1 being greatest. Okay, so again, which of the voltages is going to be the biggest? Well, remember, V is IR, true? Okay, so if that's true, and we know this, we know a couple things. IA is equal to IB plus IC. Do you see that? Oh, sorry, let me put this down. So what I would do is I would just say, like, these two are easy. We know VB and VC have to be equal. But what is VA equal? VA is equal to IA times RA. And we know that IA is equal to the currents of both of those. So it's like IB plus IC, and then RA is 2R. So the currents of both of those added together through that resistor is going to give us the biggest voltage. You see what I'm saying there? Is essentially, we know it's VA, which is greater than VB, which is equal to VC. And we know that VA is greater because it has the biggest resistance and the biggest current, so it must have the biggest voltage. All right, then we will move to C. C says, calculate the equivalent resistance of the circuit given and R ohms. So that means this is 400 ohms, this is 400 ohms, oh, that's terrible, and this is 200 ohms. So I got to do my condensation, and remember, R's in parallel. R's, resistors in parallel. Is that normal or weird? It's weird because the current's different, so we add them inverse. So I'm going to do this in little tiny condensation like this. Okay, so this is 400 here, and then this one is 1 over 400 plus 1 over 200 equals 1 over R. So that's going to be 400, over 3 ohms. Yeah. Oh. So again, this resistor was 400 over 3. This one's 400. Then I put them in the same common denominators, right? And that gives me 1600 over 3 ohms. Now it says calculate the current. So what I can do is I know that this battery is 12 volts. Do I not? So using V equals IR, please calculate the amount of current coming out of the battery. Do that now. V equals IR, I is V over R. Okay, so the current coming out of the battery is 0.23 amps. So the current coming out of here is 0.023 amps. So then it says calculate the current in resistor. Oh, sorry. For part D, it's a resistor current in resistor C. So when we come here, you see that 2/3 of the current is going to go into C. It's just a direct proportion. So what's 2/3 of 23? Like 14, 15 maybe? Because remember over here we said IA is equal to IB plus IC. Sorry. So IC is equal to 2/3 of IA, which is 0.0 what? 0.15. Oh yeah, I did the 1/3. Okay, questions there? That freaked me out because I thought I had something in my head and then I looked at the wrong solution. So does everybody understand why this is true? Because again, we just had this conversation. How much current flows through a capacitor? Yeah, it doesn't matter what it is. Zero current flows through the capacitor. So all current is going to go between these two. So do you see that I can do a condensation very quickly like this? And this is 600 ohms and 12 volts. Does that make sense to you? And we can find that current. I is equal to V over R. So that's 12 over 600, which gives me what? 0.02 amps? See, 12 over... Yeah, okay, so 0.02 amps. And if we have 0.02 amps, can you see that this voltage right here, oh, this is cool, it worked out. V equals IR is 4 volts. Yes? And therefore, this must be 4 volts. And since C is Q over V, Q is C times V, so it's 8 times 10 to the minus 6 coulombs. And that will be posted